Have you ever thought, what is lightning? What causes bright bolts to streak across the sky and strike the earth? How does it form? Well, the kinds of clouds we see in lightning storms, they have tiny ice crystals in them, and these ice crystals bump into each other, causing an electrical charge to build up, and the electrical charge grows stronger and stronger. An electrical charge is created by friction and does not move unless motivated by an oppositely charged object. There are two kinds of electrical charge, positive and negative. These opposite charges attract or pull towards each other, kind of a lot like magnets. Now, electrical charges are important to understand because negative charges exist in the kinds of clouds we see in lightning storms. This negative charge in the cloud makes some spots on the ground positively charged. Since opposite charges attract, when aligned just right, the negative electrical charges in the cloud and the positive charges on the ground attract, and a bolt of lightning jumps between the cloud and the ground. This is how lightning generally happens. Electrical charges form and opposite charges attract. And now that we know how lightning happens, this can help us form a working definition for lightning. So lightning is an electrical charge buildup inside a cloud that moves to an oppositely charged object.
Now that we have talked a little about electrical charges, let's talk about static electricity. So what is static electricity? It's a stationary electric charge, typically produced by friction that causes spark or crackling or the attraction of dust or hair. So how exactly does static electricity work? Is it magic? Of course not. Static electricity is the result of an imbalance between negative and positive charges in objects. These charges can build up on the surface of an object until they find a way to be released or discharged. The rubbing of certain materials against one another can transfer negative charges or electrons. For example, if you rub your shoes or socks on the carpet, your body collects extra electrons. The electrons cling to your body until they can be released. As you reach to touch something, you may feel that spark or shock, but don't worry, it's only the surplus of electrons being released.
You all just heard how static electricity can occur. Now we're going to see static electricity in action. This first video is showing a hair-raising experience. The balloon was charged by the rubbing of the balloon on the hair and caused the hair to stick or attract to the balloon. This second video shows the balloon receiving a charge from a sleeve and then being attracted to the wall. After hearing all of this about static electricity, you might be wondering, why is it important? So here are a couple fun facts about static electricity. Have you ever seen smoke coming out of a smokestack of a factory? Well, some factories actually use static electricity to reduce the pollution that they let out into the atmosphere. Inside of these smokestacks, there are plates called electrodes that are on the sides of the smokestacks. The factories give their smoke an electrical charge that is opposite to the charge of the plates. Then, when the smoke is released, some of it sticks to the electrodes and less smoke is actually released into the air. Another cool fun fact about static electricity involves cars. Cars are painted in an actually very interesting way. The cars are first placed in a room, and then the paint is given an electrical charge. After this, the paint is sprayed into the room with the car and is attracted to the oppositely charged car. This is exactly what happened in the video with the balloon and the hair that we showed you earlier, and also the balloon sticking to the wall. So opposite charges attracting is related to Coulomb's law. According to Coulomb's law, when you have two charged particles, an electric force is created. This goes along with what we've already heard about lightning and static electricity in this video. Another part of Coulomb's law that you should know is that if you have large charges, the forces are going to be large. So, let's say that you have a huge exercise ball and you rub it on your big fuzzy blanket. There's going to be a larger charge there than if you rub a small balloon on your t-shirt. After watching this video, we hope that you've learned a lot of cool, new things about lightning and static electricity. Now there's a question that you should think about, and that question is, are these shocking phenomena related?